One. So in the previous video, we created a class that had properties. These properties were a name and a type and the actual dictionary that holds the nodes and their connections. And we implemented set and get functions for the name and the type and the actual dictionary. And we also added a really nice function here that can print the information about the network, and it tells us more about this network, so we can learn what sort of properties and what sort of how many nodes and what kind of type, what the name of the network, and so on. So the example that we've been using from last time, we used the dictionary here like this, and I'm gonna run the cell here every time I add a new cell. I need to make sure that I run it, and sometimes I just forget. Um, so now what we need to do is to create a network object like that, and this network object is supposed to take a name, and we call this collaboration, and the type was undirected, and the third is the dictionary, which is the nodes and their connections, and we call this collab g like this. And this can actually give us, using the print function, the info here like this, can give us a really nice information. So info is not printed, I'm not sure why. Correct. I'm mixing my syntax from network X in here. So here's my info function like this. So my info function is going to print the nice information that is embedded into this graph here. It tells me that my graph is undirected. It tells me that I have 6 nodes. It tells me that my name is collaboration, as I named it. Wouldn't it be nice if we now can add new nodes? Maybe I want to add FG, and I want G to be connected to A, connected to A, and connected to D, like that, and connected to E. But I don't want to do it here. I don't want, the whole idea is to work with a class, is to hide the information from outside the class, and not to do it the ugly way here. So I wanted to make sure, if we actually do this, there is a way that we can do it inside the from the object, not from the dictionary. I don't want to be dealing with the dictionary like that. So how do I do this? Suppose I want to add a new node here like that, and I'm gonna call it add node. So here's what I'm gonna be doing. I'm gonna be adding the node, and I'm gonna be adding the neighbors of that node. And what do I need to do here? I need also to pass a self, and this self here is going to call that graph. And how do I do this? Simple. Remember that this is supposed to be a dictionary. To actually add a new node to the graph is to add a new item to that dictionary. So we pass the node to the square bracket here as a key, and the value is going to be the neighbors. And if I'm doing things right, and I hope I am, I should actually return the actual graph like that, so I can see the dictionary is fully populated. So clearly I don't want to do it this way, so I'm gonna remove it. But before I remove it, I'm just gonna take a note so we can actually make it a comment here like this. And here's what we need to do before we actually construct, before we add this node and the neighbors to the graph. Let's make sure that we run the graph with the new definition. Okay, So we run the graph with the new definition. Very good. So what do we need to do now? We need to take this graph object, and we need to invoke add node function like that. And this function here is going to take the new node, which is G, like this, and is going to take a list of the neighbors. This is a list of neighbors, and neither one of these guys have to be coming directly from variables that look like that. These guys will eventually come from data and coming from file and databases and so on. But for the sake of demonstration here, for the sake of doing things right, I'm demonstrating in the most trivial way possible. So I'm going to turn off my alarm. And now this is supposed to be returning a graph object. So this is new graph. This function, if we're doing things right, it's supposed to be doing a new graph like that. And what do we need to do? If we run this, might get an error. That's right. It did not like. So I'm gonna run this one more time. And then now I'm gonna, because we, like I said, if we run this, we also must run that one, because this is an older object that does not know anything about add node. So let's construct this guy here. The info here is the same. Now if I run the new graph like that, it's going to show me that I have that new record here. Okay, but let's take a look at the network. Let's see if the network now actually knows anything about this. Well, remember that this guy here returns an object, return the dictionary, the new dictionary. But does a network object know anything about the new dictionary? Let's check. Let's just do get the graph like that, and it says it does know something about the graph. Why is that? Because when we added the node, we used the self function, right? And we operated on the actual graph here. So we operated on this guy. So what we did, we basically added a node to this graph, and this node also had neighbors, came from this parameter here, and then we returned this. We returned the graph here, the actual dictionary. Do we actually need to return? Maybe it wouldn't hurt, but I don't see it necessary, because actually the graph itself, as you can see, the collaborator graph itself has the link to the new node, has an up-to-date version of the new node that we added, and the new neighbors that we also added. So this is looking really good, you guys. So now we were able to add a node. What do you think of the idea of given the new dictionary here? I want to use that new dictionary to populate a network X object, so I can visualize it. I really want to visualize it, so we can see what it looks like after we added these after we added this new node and these connections. None of these guys were new nodes, because we had an A and a D and an E. And if you remember from let me just do the import network X as NX like that. And I'm going to create a graph. This graph is going to be populated from the dictionary that I returned here. That's why you see it's really nice now to to get this graph from here, because we have a get graph function, and this is gonna give me my new collab G, like that. So let me run it. Okay, we need to make sure that network X is invoked. Okay, so now we have a new graph coming from network X. Let me also do to print the info on that graph. I'm mixing the syntax here, so please forgive me, because now the info here belongs to NX handle, and our info belongs to the object. But I think this will do, like this. So it's actually working really nicely here. Now the purpose of me doing this, it was to actually print, and not only print the info, but also draw the object as well. So let me draw the actual graph, and I want to see the labels with labels equals to true, and I want the color, the node color, to be red, like this. One more time. As you can see, so the G here, this is the new one, it had connected us to the A, and connected us to D, so it created this triangle here, and it also connected us to E, this one here. So E is new, and D is new, and A is new. So 1, 2, 3 edges were added. So let's take a look at the previous one, if we still have it. I don't believe we still have the older graph. Let me see. Right. Do we have it here? I don't remember if which one. I must have closed it. It's okay. You can go back to the previous, network that we drew, and you will see that our new graph now is looking more complex. So this is really fantastic. We can actually also delete a node. Suppose that I really don't like this relationship between C and A, and I want to delete it. So how do I do this? Let's define a function, delete. Well, let's call it remove node, like that. And it's supposed to take a self, and it's supposed to take the node, because I don't know the neighbors, but I know that I need to remove that node. So what I need here is to grab, because remember the graph is a dictionary. If I apply the delete function, it's a keyword like that, and then I can also return as well the graph after I delete the node of interest. So now let's run this one more time. Okay, and let's run this one more time. So when we operate on the object, it will know remove. Okay, now let's run this. We have not removed anything, like that. So it's basically telling us that we have 7 nodes. 1, 2, 3, 4, 5, 6. All right, because we actually added this. So let me run this one more time. Yes, 7 nodes, because we added this after that. All right, so if I run this new graph, and I like that, I get it here correctly. Now I don't want to mess with network X. I just want to remove this guy here. I want to remove C and A, and let's see what happens. If I remove just C by itself, I will show you what happens. So let's see, let's invoke remove node, and what I want to do is to remove C. Okay, so if I remove C, everything that contains C or connects to C will also be removed. So there won't be connections. So if I remove C and A and C will also be removed. And if C is connected to anything else, it will also be removed. As a matter of fact, I'm going to do this after I see this graph here. So now, let me see. Because, so now we removed C like this. So C is not here, is not in the keys anymore. So we removed it indeed from the keys. As you can see, C was here in the keys, now is no longer in the keys. As you can see, that it's in the values here, because we only broke the when we removed it, we removed the actual key from the dictionary. Let's just visualize it. But before we visualize, we need to make sure to get the graph after it has been updated, and we're going to construct a new one, a new network X. Let's call it 2, like this, and I'm going to pass network X2 object to the we need to draw. Let's do the draw function first. Okay, well, we need this guy to get graph. Okay, here's what we're doing. We are doing some really silly things, because now new graph here is a network X guy, so we cannot invoke new graph on it. But what we might need to do is to grab our graph object, which we called what? Collab G, like that. We need to call collab G. Collab G is going to return a new object, a new dictionary, and we're going to pass it to network X that will create a new graph of type network X graph. There we go. It says the number of nodes are 7. Well, clearly is no longer 1, 2, 3, 4, 5, 6, 7. Not sure why. We should actually, when we remove, we delete it from the graph here. So when we get the graph, we are supposed to get rid of one less node. Well, the number of nodes will remain the same. The number of nodes will remain the same, because C is still a node, but it's just the connection is gone. Okay, because some other nodes are connecting to C, so we cannot really delete it from the other values. So that's why we have 7 nodes. Okay, now let's draw. So we can compare the drawing. That drawing will actually make a lot of sense. So we're gonna invoke the draw function of network X again, and we are going to draw with labels, so we can see what labels are being drawn. And we want the node color to be red. Okay, as you can see, there is a missing link. Where is C? C used to be connected to A, still connected to A, still connected to A. even though we removed it from the keys, it still has not been removed from the graph because some other nodes A here is still connected to A. And remember when I said this is an undirected graph. So here's what we want to do. We want to also delete A like that, and then we might be able to see something much more significant than what we're looking at right now. So let's run this. Now we're seeing less nodes. Here you go. Now we removed C and A. So C is already gone entirely, but because we also removed C, and A was already connected to it, but now A is also no longer connected to anyone, so C was entirely removed. What we might need to do better is to actually enhance this remove function. Then if we want to remove not only by node, but we also want to remove by edge. So if there is an edge between C and A, and this is an undirected graph, then we also want to remove A and C as well. So we want to remove the two sides. We want to remove both A and C together. And then none of these guys will eventually have any other nodes. And so there won't be links then. And then D and B will become loose nodes that they are not connected to anything because A will be gone if we remove C and A. I think this is really good. How many nodes? 3 and 3, that's 6. Here 4, 5 and 2, this is 7. This is a good demonstration, and we are going to continue to work with the graph manipulation in the next video and then in the next lecture. So we're going to add a function that removes edges and then update nodes and so on. Thanks for watching.